Okay.
Hello, everyone, and welcome to AWS Heroes in Conversation. Today we have Goran Opacic with us. So, Goran, welcome to the channel.
Hi, everybody.
Hello, thanks for coming. And Goran is going to today talk about Lambda SnapStart. So, Goran, before we get into the topic, can you please go ahead and introduce yourself to our viewers?
Yeah, I'm an old guy. I do Java. I do databases for like billion years already. That makes me like maybe a perfect person to talk about Lambda SnapStart, because
Okay.
Lambda SnapStart is a product that came into AWS world because of the need to move some technologies and projects which are done in the last maybe 20-30 years, all that knowledge that was used to make all these projects, uh, uh, and but it was hard to move these projects to serverless and some latest stuff. So yeah, I have some experience in these older technologies, so that's why I enjoyed when when AWS said, okay, we need to do something to bring all these apps into the cloud. And also I'm doing a lot of databases. That's why they called me now an AWS data hero. I love
Okay.
MySQL. That's my like preferred database, and all about MySQL. And I do a lot of meetups, events for the community. Enjoy it. Yeah, that's pretty much it. You can find me on Twitter,
Perfect.
Mastodon, whatever.
Awesome. No, that gets us excited. So, something so much. I think let's get started with this topic, and
Yeah.
it would be good to know a little bit more about Lambda SnapStart. So, over to you,
Yes.
Goran.
Yes. Thanks for reminding me. So this is like a small thing in terms of like how users may perceive it, and like a one click, to enable a feature. But then when you look at what's behind and what improvements it brings to the table, it's incredible. So if you know about AWS Lambda, you know that AWS is doing a lot to start that simple function in the cloud. They need to take the function from some storage, bring it to some machine, then create the virtual machine so your Lambda doesn't affect other machines, and then it has to run it, run your code into it, return this response to the customer. And all this could be done in maybe in less than a second. And even if you have a function which is your code can be like maybe a gigabyte or something, it is still finished in 1 second, or less than 1 second. They even charge you for a millisecond. So it's an incredible amount of work that has to be done in such a short time.
Yeah.
But still, even if no, because customers, we as developers, we are never happy. They make something like they charge us per 100 milliseconds, and we were not happy. We said, oh, you should charge us for per millisecond. And then, well, AWS delivered. So that's why AWS's serverless offering is like a billion times better than anything in the market, because they're really pushing it to the edge. They try to make it super fast. So even if with all these things, we have some old apps.
Okay.
Not only old apps, we have big apps.
Mhm.
And big apps means that you have to bring your data to your application. You need to start a lot of functionalities before even the first execution comes. You have a website that runs, but then, well, you need to load the driver for the database, collect some data from, I don't know, Excel sheets, maybe machine learning models or stuff before you even execute the first call. So all these things, they all take time, especially with languages like Java. It was never meant to be used in this way, because Java was running on servers which were run on premises, and it didn't matter like what was the cold start of a server. You just turn it on and then wait for a couple of minutes, and then when it's running, it's super fast. Java is amazingly fast language. It's incredible. It's not just it's not because it's like a super fast language. it's because of the virtual machine that does analysis of the code during the time of the execution of that function, and it can change the machine code, which is better because maybe you're using in some places you have a for loop, maybe some other places you have some other way of looping through data, so the Java virtual machine is smart enough to analyze the code and say, oh, we should change the machine code for this, or simplify it or make it more complicated, but it makes it much faster, so once you have it running, Java is super fast. So but the problem with Java is that, all that time that it takes to load the data, load the classes, prepare the system before we have the first execution, that's what made Java like the worst offering in terms of serverless. So you have your old code, you want to move it to serverless, but then you try it, and then you realize that in AWS, you still have cold start of your function that can take 4 or 5 seconds, which is in comparison to maybe someone who is using Node.js, that's super slow, because like in Node.js, you can have like 500-600 milliseconds of cold start. So what's the cold start? It's all that time that needs the function, that function needs to just to become hot, so that it can accept the first call. Okay, so AWS was smart enough to say, okay, so let's see how to take all that time that you need to warm the class, the application, then let's warm it. Let's make it warm. Okay, let's execute all that code that needs to be done the first time. Then let's freeze it, keep it somewhere in the storage, and then when the customer is ready to make the first execution, you will take that, unfreeze it, and then execute it. So you will have not only your code, but you will have all these things that were executed on that first execution. I mean, on that warming up, during that warming up period. Okay, so all these classes, everything that's in memory will be there. So how is AWS achieving this? AWS is actually taking that virtual machine that holds Java virtual machine in it, that holds your code in it, that holds all the data in the memory. It will make a snapshot of it, save it somewhere, of course, in S3 storage for us, and then on the first call of Lambda function, we will just take that virtual machine, load it, and then execute the code. All this time, all these activities that they have to do to load that snapshot back, they take no more than maybe 200 to 400 milliseconds. So even if your function is super complicated, so for example, you have functions that need to load a lot of data. It may take like 10-15 seconds to load some huge amount of data, start all the Java classes, even with all these 15 seconds cold start before, now it will take only 200 to 400 milliseconds to start it for the first time before the first execution. So doesn't matter what kind of a code is. Now you get your virtual machine ready for the first call in 200 milliseconds, and that's the biggest benefit. That's pretty much it. Like in terms of what AWS did. But it's not only that. If you go deep down into what they did, you'll see amazing work. That they had to do to achieve this. So, for example, like they're not loading. If your virtual machine is like 3 gigabytes of RAM, they need to take a snapshot of the entire virtual machine. But of course, once you start the function for the first time, you don't need all the pieces of the operating system that's there in the snapshot. So they actually managed to cut these virtual machine snapshot into slices, and then as you call this virtual machine, they only load what you need. So the time load the snapshot is much lower than someone would expect, because Lambda virtual machines can be like 10 gigabytes now, so it's a lot of storage, that you have to load. So they load it, they'll only load what they need. So these things are super hard, that's not easy to achieve. So
Yes.
so this is, in general, this is what they did, but of course there are many challenges now for people who want to use this feature, and I'll try to address some of these things. First, let me show you just what are the how it looks like, in terms of like Amazon Web Services console. The only thing that you will notice is that your function now has one more feature, called SnapStart.
SnapStart.
Yeah. So if you already have a function, unfortunately it's only Java now, but Java is one of the best targets for this feature, but eventually all the runtimes will get the same feature at the end. So you only need to enable this SnapStart feature. It says the value for SnapStart is called published versions. That means that, well, of course, it's not a simple change. Now you need to enable versions on Lambdas, so which is an old feature, of course, but not many people are using it because it doesn't bring benefit to everyone. But well, you should at least read about that and see the benefits. It's used mostly for blue-green deployments, where you can have one version getting ready, tested, and then when it's ready, tested, it will be deployed. You can gradually deploy one version, maybe only 10% of the traffic can go to that version and stuff like that. So you can see the impact of that version, and if everything is fine, AWS will automatically replace your version. Here, AWS is using, you must have versions enabled in order to use SnapStart. That's because they need to make a snapshot for every particular version
of that version.
Okay. Yeah, that's from the perspective of of console. This is the only change that you can see, of course, and then you see versions and aliases that need to be enabled, of course, for this to run. Okay. Let me show you just like if you're using CDK, for example, you need to just apply a simple extra parameter to your Lambda function, and that's it. You just enable this property SnapStart and put this published version. This is it. Unfortunately, the CDK and CDK doesn't yet have this like a first class properties for SnapStart, but this is enough. And then if you just add this, it will enable the whole thing. Of course, you need to start using versions and aliases, and that's the only change. So from perspective of CDK, which I use mostly to deploy my functions these days, this is it. This was enough. Okay. So let us see what are the differences between two versions of functions. Let me try to call first the function with no SnapStart enabled, and let's see the time for it to be executed. So it was 4.9 seconds for a call start for a function which doesn't have
with SnapStart not enabled.
Yes, not enabled. Okay, so let's see how it works with SnapStart enabled. It's 2.2 seconds. Okay, but this is super heavy function, and I'm not saying I'm not talking about functions which maybe connect to for example to DynamoDB or some local AWS services. This function needs to do a lot, and I mean a lot in a way that it needs to load the JDBC driver, connect to MySQL database, get some JSON, parse it, and do a lot of stuff. So this is just the beginning, because this function that I showed here, it was not changed in any way from the original version that was there. Okay, but there is something new in Java world, which is called CRAC, CRAC. It's the idea of that technology is also to do some kind of a snapshot of virtual machine and then restore snapshot of virtual machine, but it's only related to Java virtual machines. Okay, so what this technology calls us to do, they say, well, if you want your application to have everything that is ready before the first execution, you should do some more job, smarter job. So they provided us with two functions that we can execute in our code. So our virtual machine can be richer. Let me show you. Like so there is one function that is executed before the AWS or Java is doing has created the SnapStart, the SnapStart snapshot. Okay. In that function, you can add some code that will load classes that you know that you will use during the execution. Okay. So if you, for any reason, didn't use this any of these classes during the call start, well, and you know that you will use it later, you can load classes before this call and then freeze them together with other things in the snapshot. So that's called priming. You know, you can load the JDBC driver, everything in the JDBC driver. So in this example that I did, I didn't do any of these things, you know. So from 4.9 to 2 seconds, it was no code changes, you know. But with extra work, I can bring this call start to 600 milliseconds. You know, that's something like that is very important. But it needs an extra effort from a developer to do this kind of priming. You know, so what's priming? You know, you whatever data you need later, well, bring it on. Just take it, load it now. Whatever classes you need, just load it before you need them. Okay. So the good thing is that new frameworks in Java world, like Quarkus, like Spring Boot, like Micronaut, they all have some capacity to do these things for us, and hopefully they will do that. You know, so we don't need to do this extra work. These frameworks will do these things for us. So that will happen in the future. This priming. So this is not only a feature of AWS SnapStart. This is a part of like the movement from in Java world called CRAC that will bring us this snapshotting and restoring of virtual machine. So everyone is working on that. It's not only in AWS SnapStart. But the good thing is that AWS has used these libraries and enabled us to add some extra code at this place before the snapshot phase, so we can do that same thing, you know. So we will all benefit from this CRAC technology. Okay, so what AWS did, you know, that AWS is like probably the first to bring this thing to the market in such a way. You know, now you can do the snapshot and restore it in Java in the serverless world. Well, that's like in a couple of 100 milliseconds. That's something like a even if you look at the state of AWS now, you know, they're kind of slowing down in terms of bringing new features. You know, for example, Java 17 is out for more than a year, and they didn't release the runtime for Java 17. You know, so everyone is complaining, but well, they delivered this, and this is probably more important, and they really executed
and Java
well.
17.
Yeah, Java 17 is great, but it's maybe like not so important that people would cry, you know. But with this, well, this makes such a huge improvement, you know. So in terms of like, well, what's the difference between 1 second and 6 seconds? in terms of the background services that do some job. For example, like you have to prepare some email with attachments and do some processing of emails. Who cares if the email comes in 1 second or 6 seconds? If it's a background job, okay? And you have if you have a lot of queues which do some stuff in the background, doesn't matter. But if you have a front-end facing website with the APIs where people have real-time requests that need to execute in less than someone would come in less time that's needed someone to come.
Yeah, that would make a lot of difference going down from 4 seconds to 600
no one wants to wait for a website to load for more than a second. So
yes,
second is like a magical number. So after that, you just start reloading it. Something is wrong. You feel pain. Okay, you're not happy with so with this, we can finally say, okay, even this website which was sleeping because no one was using it at the moment, in the morning, and you start your application, people start logging in, and those people that start with using it will first feel this pain of cold starts if your application is done in Java, But with this, everyone is kind of fresh and gets super fast. And I really feel that, and I have this in production already, and I say that this is the first feature from the reInvent that I enabled it immediately after the reInvent and made such a huge impact. It's not about the money, it's about the perception, of the customers, that now they feel that the website is snappy, everything is super fast.
So you did get some feedback from your customers after you enabled it?
Yeah. It's everyone can feel that. For example, like it's not only the website how it works. It's for example, you can see that in the process of logging into your website, and you have a login screen. It first needs to be displayed. You have to get some data to display login page, and then you need to send that data to get some tenant information or stuff. Then you need to call Cognito, which would call your authorizer to do something in the background, And then, so there's many things that happen during the login process, and these lambdas wait one for each other, so it's not one lambda call or like 5 simultaneous calls that will finish in 5 seconds, 6 seconds. So one call waits for another call, another call. So your login procedure can take like 30 seconds, It's just like ridiculous. It takes too much time. And a login page is not the hot page, you get there like once a day or something, and it gets called again. So all these pages which are like not those that are used frequently, well, they suffer. So, but if your website is really hot, if you have a lot of customers using it, you will probably not feel this. That's another topic. So this can bring a big difference to those phases of your work of your application or places in your application, or to these parts of the system where one lambda is chained to another lambda.
Okay.
We need to, these things are really impacted with the cold starts. So in terms of like what do you need to do? Well, you need to just enable versions, and that's it. Okay. The problem now is that this version has some limitations. Okay, so first limitation, it doesn't work on ARM, and well, almost everyone switched to ARM, because with Java there's no, you don't have to change any code, and that just works, and then it's cheaper, and it's super fast. But now we had to go back to Intel, so okay, well, doesn't matter, but still it takes time, to change these things, because first you need to switch to Intel, and then you can enable SnapStart. Like, so it's a bit complicated to, if you already switched to ARM, to get back. Another problem that we see is that these snapshots have an expiry date of 14 days. Expiry time of 14 days. So it's so if you don't use your function for 14 days, then only then, after 14 days, first call will fail, and then we'll asynchronously initiate the creation of a new snapshot, and then when the snapshot is ready, well, all the calls will be successful, but during this period of time, it can take like 1 minute, for the system to create the snapshot. All your calls will fail. So if you have some lambdas waiting for something, for example, people usually drop files to S3 and then make an event trigger that calls lambda directly. Well, maybe there is in these cases, if you want to use SnapStart, you should add SQS in between, because otherwise your call from S3 system to lambda will fail. Maybe there's going to be one more attempt, but that's it. So but if you put SQS in between, it will try multiple times and until the message is expired, so it will have enough time to try again and to deliver that message, so makes sense. This is really one of the examples where you need to change the infrastructure because of this feature enabled. Really, you need to really think about how can will this thing have an impact on some places in the code. Okay, it's not to go and
revisit your architecture, the application architecture, and make it more asynchronous, I guess.
Yes, and really, you need to make it safe. I never thought that calling a lambda directly from S3 trigger was safe. I always felt that, well, there has to be a queue between these two things. This is risky, if for some reason this call fails, what then? So putting SQS in between everywhere, it's not that bad, so it will keep the system safe, So one more thing which is also like important is that this creation of a snapshot, it's done in the it's happening in the during the deployment of your CloudFormation stack. So it doesn't take any time during the execution of the application, only during the deployment of your stack. Okay, so these 1 minute of creating a snapshot, it can take time. If you have like 10 lambdas in a stack, it can take more time. Okay, it's usually done in parallel, so it doesn't end up with like 10 more minutes, but it can add like extra 1 or 2 minutes to the deployment of a stack. Okay, but there's another problem here, that if you have a bug in your Java code during the initialization phase, well, your stack will not be deployed. It didn't happen before, because previously AWS didn't care what's in our code. They will just deploy the function, and then during the runtime call, the call will fail. But now, init phase must be safe. You have to execute it properly. Otherwise, well, your stack deployment will fail. So that happened to me a couple of days ago, and well, we were like really, because there was a function that no one was using, like with some bugs in it. We didn't care. No one cared about that. Something left behind, and then the entire stack deployment failed. So these are the things that you have to think in production to get this running. Also, like when we talk about this cold start, previously we had term called cold start, but now we have thing which is called first execution, because it's not that cold start anymore, but still you have this resuming of a virtual machine, and also there can be some issues, because when SnapStart when the snapshot is reloaded, it can have some database connections or something left behind, from the snapshot, from the virtual machine. So if you try to reuse them, they will fail. So the problem is that maybe you will have extra time in your system to fix some stuff, before your code can safely be executed. That's why they introduced something called after restore. So you can put a function that happens after the restore of virtual machine, but before the first execution. So you can clean up some stuff, like especially maybe some kind of random code, random number generators, or database connection stuff and stuff like that. You should just kind of clean them, and then you can execute your functions safely. So it can actually add some time to your first execution. Okay. And another thing that is,
but that's only for the first execution, right?
Yes,
not
yes.
after that. So once
Yes,
it's done, it's done. Then
only first execution.
Yeah.
Exactly. Yeah.
first
So
execution.
yeah, in Java world, there is a big fight, now to get between these two technologies, between Crack and GraalVM. So let me just for a second explain that, for the last couple of years, Oracle was forcing, they created something called GraalVM, which is a lot of products in it, but the main part of it was the ability to compile Java to native code. So you could get it, you could get your Java code compiled to code for ARM CPU, and then execute it natively in ARM CPU, and you can run it as a Lambda, and then you can get 200, 300 millisecond call starts. So it's also very good, but it's not easy. It's not easy to achieve, because you need to do some code changes to get it running. You need to understand the entire world of what your application will use during its lifetime, and you need to prepare everything, absolutely everything. You cannot miss just one thing. For example, one driver or something, and everything needs to be compiled in native, and then it can be deployed. If you miss any function or any class, if you try to load it dynamically after it's started, it will fail. So the GraalVM brings, a lot of joy in one term, in one way. It really helped everyone running Java in a super fast way. But then you really need to put more effort to test it in some real world environments. You are not sure that something that you build will run. So that's a big problem. You really need to test it. So, and with SnapStart and Crack, you don't have to do any code changes for Java to work. That's really important. If you have a legacy code, if you have any kind of application that is done in the last 10, 15 years, they're still working everywhere. Whatever you do now, you have Java doing something. If you want to bring these things to new platforms like Fargate or Lambda, well, you have, it's super hard to go deep in your code again and again and analyze it and do all this kind of deeper thinking, and change code just for it to be so the code can run in GraalVM. Okay, for example, to update it to use the latest libraries. That's so hard. Like just changing it for even the slightest thing in Hibernate or JDBC, like everything can fail. So it's super hard. And so this is why people are more happy about Crack and SnapStart, I would say, than GraalVM. I think everything good about GraalVM, but still this makes
This is more easier. Is it more popular? And it can give you 50% reduction in execution time without doing anything.
Yeah, you get a lot, and without changing code. If you put some effort, you will get even more,
More
like
effect, yeah.
more and more. Like this cuts time like for even five times, for example. But if you do more, you can get it five times more. So this is really good. But it's also a problem with a lot of effort that is already put into this. GraalVM is really now kind of a established technology already, so it's kind of three or 4 years already on the market. So we'll see. I'm super happy that Java world is so young now. We have so many new things coming out. So and of course, as I said, AWS needs to move all the applications, not only new applications. We have so many applications that use some Java EE, Jakarta EE stuff. Everything has to be able to run in serverless. And the good thing about frameworks like Quarkus, Micronauts, Spring Boot is that they enable us to, with these days, enable us with all these technologies to do that, to do exactly that. To just take the same code and run it in Fargate or Lambda or any other cloud. And so that's pretty good opportunity for people who have done some applications previously in on-prem or in some other environments.
Environment. Okay.
So there's some small changes that people will notice also in the log. So this is something that I have complaints about with AWS, that they kind of introduced new keywords in the log for Lambda. So now you can see some things like init duration, which means that like the execution time during the snapshot creation. Okay. Then you have things like restore duration, build restore duration. Well, I mean, no one knows exactly what these things mean. So AWS doesn't have like a clean explanation, and we think that they need to be more transparent about this. That's why if you look at some of the good blog posts that I show here, one of them is from my friend Vadim Kazulkin. When we test these new features, we don't trust these logs 100%.
Don't trust the logs, okay.
So we always use, as in my example, I used an external call through API, and then I measured the total execution time. I don't care what they say in their logs. I just want to see the total number, like, is it 2 seconds, 4 seconds, something like that. Because if the log says it was 400 milliseconds, and I see that in my browser that it was like 2 seconds, well, okay, guys, I mean, just make it more transparent. That's I think that.
But that 400 milliseconds is only for the Lambda execution, right? But when you're taking 2 seconds, that is end to end, right?
Yeah. But the API gateway brings maybe 10 to maybe 100 milliseconds, never more. Yes. Like, that's nothing. But there is something, that there's many things that happen during this execution
in between. Yes.
Yeah. So for example, like as I said, they don't load the entire virtual machine. They only take pieces. So what happens if I need more pieces? Well, it may take more time, and this is something that the virtual machine restore, it's not completed, during this init phase. It may be there is this initialization of the virtual machine. It can be maybe done after that. So you see that there is an impact here, so that we don't understand. So AWS has to be more transparent. For example,
but then shouldn't we ask them, like, to your point?
Yeah.
So there's a build duration, there's a restore duration, and there's build restore duration. So don't they kind of mention that, hey, you've been billed for this much amount of duration? Does the build duration incorporate the build restore duration or no?
Well, you see that clear questions, and but we don't have answers, so we'll see. but okay, I understand that this is like a super hard thing to do, and they did that in the super short time.
Right.
And for me, it's fine. But I see the final benefit for me that I actually get almost everything running in 1.5 seconds, 2 seconds, like anything. Whatever I bring to the table starts in 1 or 2 seconds. That's
nice.
I don't care then. Like
without making any code changes.
yes, exactly. So I don't see. I don't want to push too much now, because the thing which is missing now, for example, is X-ray. You know, they don't have support for X-ray now, and when they enable it, it will be much clearer. You know what exactly is going on. You know, like during this whole execution time. So okay, let's be fair. Like I don't want to complain on every feature that's kind of strange or missing or something. I just want to be positive, and because this is super positive feature, you know. So
it'll take them some time to get there, I guess, but eventually they'll get there. It's the first version, you can say.
Yes. This is like a this product is now in production, and I use it, and I'm happy. You know, like name some other products in AWS which were so good in production on day one. Like, well, okay, that's hard to find, you know. So anyway, so we need to understand what's going on now, and we need to get more information for them, but it's coming. So we had one very good Java AWS Java panel in last week. So we really tried to discuss what all these people had in mind when they complained, and what is this all about. So yeah, there's already some more material on the net, so everyone should follow. So in terms of like production experience, I would just name one more thing. It's that it was, people were complaining, but it's actually clear now that when AWS is doing a snapshot, it doesn't only create one snapshot. They create snapshot for every availability zone that you have your Lambda deployed. So if you have 5 availability zones, well, they will enable all of them, you know. So it's that's something that is strange. You need to understand what's going on. You're like, and if you are working in a region with more zones, it can be like 6, you know, deployments, and it's also important for people to understand that even if you use this Lambda with for example 30 seconds timeout, your snapshot creation time can be anything up to 15 minutes. So you can do a lot of executions, a lot of preparation of your data. For example, you can load billions of records, do some calculations, save that data, and then let AWS create the snapshot, you know. So with this aggregated data, you do further executions, you know. So you can take 15 minutes to finish
initially to kind of do all of that, and then have the snapshot, right?
Yeah, okay. So it's not the same time as the maximum execution time. Okay. And also, like, if you do some smart things during these 15 minutes, well, the Java virtual machine compiler will kick in, you know, and understand, oh, I have a better way to make code. So whatever you do will impact the final snapshot. Okay. So if you know how to do some analysis of your during this 15 minutes, well, you can make super fast, super smart function for the later executions. Someone said, Mike Roberts on Twitter said that, well, this is another way to do some kind of blue-green or other deployments, because, you know, now if function fails during the deployment, it will not be deployed. So if there is some kind of an error, it will not be deployed. So you can do some testing, you know, during the deployment by just putting things in before snapshot phase. And well, if it fails, your function doesn't work, and then it won't be deployed. If it passes during this execution, it's okay. So you're good. So this is something also people can think about. Simple way to do some kind of a testing, last minute testing before deployment.
Testing.
Yeah,
absolutely.
So I just want to point to two very good blog posts. One is the six-part series by Vadim. With results which are really good. If you look at the screen, you can see the execution time based on what logs say. But in the real time with the API gateway, it was more like more about 1 second. Okay.
1 second.
But these are the execution times, and you can see here that even the Spring Boot, which is the slowest of all frameworks, makes results which are very good. Like you can see that results like 600 milliseconds or something.
Yes.
So it's super. It's great. So that proves what I said, that it doesn't matter what you bring to this.
It will still kind of get it done in like 1 to 2 seconds.
Yes, exactly. You see. So, and another one is the very good post by Mike Roberts, who wrote the book about Java and serverless, is that talks about issues during the creation of these snapshots, and how hard is it to create a good primed function, to get everything loaded before you execute that. So, but it's not super hard. We hope that in the future frameworks will help us and automatically analyze what we use in our application, and then bring these things in the up during the initialization, so we have these things in the snapshot. So once these frameworks are ready to deliver this for us, well, we don't. After that, we'll probably get automatically these benefits without any kind of extra work, without any kind of extra coding, But that's not yet there, so we'll see. Hopefully during this year.
And I will have these URLs posted in the description of the video as well.
Yes.
You also have the QR code over here, so that's excellent. Anybody who wants to kind of just scan the code and take it ahead from here as well can do that.
Well, perfect. That's it. You can find me on all these networks. I always discuss about these technologies. I always complain. I'm free to say anything I don't like or I like in the AWS. And that's why I really like this Heroes program, where people just are free to complain.
You're free to talk, yes.
Yes, this is...
No, absolutely, Goran. That's so true. This was amazing. I think this is an absolutely great feature. It is very handy, to your point. And a lot of people who have these Java apps, especially in production, can certainly experiment and play around with this feature, right? Just to see what's the difference. Like, do their customers like it? Do they themselves feel the difference of just enabling a small feature and not making any changes to your code and still gaining like 2 seconds without doing anything else? To your point, if you put in a little more effort, you can bring that 2 seconds down to 1.2 seconds or maybe 1 second. But if I'm getting 50% without doing anything at all, I'll take it. I'm not changing anything. I'm not doing anything on my side, just enabling a feature. So this is excellent.
Yeah. Not only that, you don't have to change your code. You can bring things which, because of these cold starts, people were thinking, oh, okay, I need to run it in Docker, in containers, or something,
things like that.
But now, when it can start in 1 second, I can move it to Lambda. I don't care. So this is totally. One day we'll really have stuff like I don't know, WordPress or something, like these heavy lifters. We need to bring them to Lambda. We don't.
Absolutely.
We cannot.
Right now, also it works with all the technologies, right, including Spring Boot. You said so.
Yes. So so at the moment, this is only for Java, But if you look what other people need, especially people who are doing machine learning and using Python and stuff, they need to load complex models, do the analysis, prepare the model, and then then Lambda can execute. So you can also bring a lot of data in the virtual machine, in the memory, not only in files. You can bring it in memory, and then you can reuse it. With this, you put all that effort in this before snapshot phase, or during the initialization, just put all the code, do all these things, and when the code is when everything is executed, system will just do the snapshot, and that's it. Now you're ready to execute. So not only Java, needs things like this. It's all
Other
languages
as well. Yes,
I would
probably
say that
Python,
any kind of
.NET.
business related application that needs a lot more data, just not just like forwarding JSONs back and forth. This is for real business,
real applications. Yeah, .NET,
yes.
Python could be a couple of others as well, but at least
Yes,
those two come to my mind because .NET and C# especially is very similar to Java.
yes.
Very similar languages. So no, this
And
was
very similar
amazing.
problems. Very similar problems
Yes,
that
very similar problems as well.
yes,
Yeah,
exactly.
and if you can get it sorted out for one, I think you can get it sorted out for others as well. It's going to take them some time to get to the other languages, but at least they got it done for Java at this time. So this was awesome.
Yes.
Thank you so much for coming, and this was a great session. So thank you for
Thanks.
sharing your knowledge with us. So thank you.
Thank you for calling me. Bye bye.
Absolutely. Bye bye.